my name is DylanKimball, and this is my code review for CS499. So in this review, I will be going over 3 separate artifacts that I have chosen to enhance for the 3 categories of this class, which is software engineering and design, data algorithms and data structure, and databases. So for each artifact, I will be going over the current functionality, the problems and inefficiencies with the current code, and my plans for enhancing this code and meeting the outcomes of the course. So starting off with the first category, software engineering and design, my first artifact is from the CS330 class, computational graphics and visualization. So this project was meant to render an image of my choosing, and for my choosing, I chose an image of my desk, which contains my 2 monitors, a stuffed animal, a tarantula, and a water bottle and baseball. So starting off, we have here all our definitions for the different variables we are using, and then a few function definitions for our input to get user input from the keyboard and mouse. And then we go on to our definitions, which define our position and rotation of multiple of our objects. Once we define those, we get into our error checking. This error checking is just in case the shader or OpenGL has a problem. We're always checking these, and if something happens with the shader or OpenGL, we're going to know about it, and this is going to throw those errors. Next, we have our draw functions. We have one draw function for the rectangles, a cylinder and sphere, a plane, and the light. And each one of these are fairly similar to each other. The first thing we're going to do is essentially transform the model matrix, and then once we have transformed it and we've gone through all our proper loops, we are going to pass it to the shader and actually draw the elements. And that's very straightforward and similar for each one of these functions. And moving on from those, we get to our functions that actually create the shaders. So the first thing we're doing is set up our initial camera positions, and then we have our function for our shader compiler. This creates the shader compiler and then also checks it with that error function we have before to make sure that it's working. If it does, then we can return the ID. Next, we create our shader program in a very similar manner, getting our fragment and vertex shaders, checking the error to make sure it's working, and if it is, then we return the shader program. Our next function is for our shader source code, which contains all our positions, text coordinates, and normal values for our vertex shader and our fragment shader. And the fragment shader also contains all of our light values for the different lights we are using, which is ambient light, and then we have 2 lights for the diffuse light, which is just kind of the basic light that the light objects give off, and then the specular light for each one, which gives us those highlights. And then we have our vertex and fragment shaders for each of the lights. Our next function creates our vertices, which is what allows us to actually build each of our objects, as for instance, all of our monitors are based off of these vertices. Everything is built off of them. And this is what gives us our UVs and our normals and our vertices. And then we also get our indices down here. And then we actually create our VAOs, VBOs, and EBOs for each one of our vertices that we defined. Once those are created, we get our textures. We have quite a few textures relating to this render. So we're basically generating our texture objects, checking to make sure that we actually have that texture and can load it, and then adding it into the scene. Well, not adding it yet, but adding it so we can use it. And then we do that for each one of the textures we use. And that is the end of this function. Our next function is just view mode, which changes between perspective and orthographic based on the user's input. And we'll get to that in just a second after the next function. but this is now our main function where everything actually happens. So the first thing we're doing is setting up our initial positions, creating our window, initializing the library, initializing our shaders, and initializing our user input. And that's essentially what all of this code is doing, is just initializing everything. And then we have some error checking to make sure everything is initialized properly. If it is, that's when we get into our render loop. So this render loop is going to stay active until the user closes the window. And the first thing that's going to happen each loop is we're going to check for keyboard input. And then we're going to get our shader program, get all of our matrices and locations, set up our lights and light locations and matrices, get our current view mode, our current view matrices for the camera, and then we're going to enable some stuff for the actual depth and operations that we're using. And now we get to the part where we can draw our objects. So we're going to bind our texture and our VAO that we want, draw our object, and then unbind those objects for the next ones. So as you can see, the first one we draw is a plane. Then we draw our first monitor, our second monitor, then the cylinder for the water bottle and the tarantula legs, and next is the sphere for the baseball and the tarantula head and body. With everything drawn, we then create our lights and draw our lights into the scene. Our next functions down here after the main function is actually what allow us to get the callbacks from the keyboard and the mouse. So the user using the keyboard is able to escape to exit the program, use W, S, A, D, E, and Q to move backwards, forwards, left, right, up, and down, and then use P to change between that perspective and orthographic view. And then using the mouse cursor, we can actually look around the scene, and using the mouse scroll wheel, we can change the speed of how fast we move. So we'll just get a quick look real quick at this in action. So once this loads up, we'll see right here, we see the scene that I've been describing, my two monitors, the tarantula, baseball, and the water bottle. And then our two lights right up there. So you see everything works properly. I'm able to move around up and down, change to that perspective camera, and then back. And then the shading is working well with the lights. You can actually see if I come down here, that specular light on the monitors up there. So now we can get into the actual analysis of this. So the first thing I want to point out is just one error that will need to be fixed with my enhancement is the texture of the monitors. Every other texture works well. However, the texture of the monitors is clearly off, and this needs to be fixed so that we can have it be straight on and match to make it a little more realistic and more professional. Now we can exit out of here. And when it comes to formatting, the formatting of this project is fairly well done. Everything is spaced out, everything is indented properly. You give space between different kind of sections of code so that it makes sense instead of everything being grouped together as one. And there's not really much here. As far as I am currently aware, that could be replaced with different libraries. I'm sure there's some stuff out there that would definitely be able to improve upon this, but I have not yet looked into what those would be. When it comes to commenting is pretty well done. Everything has a kind of valid comment related to it, telling you what it is, and kind of these comments here telling you what starts here, what ends here, what's being drawn currently. However, there are some areas I feel that may be commented a little too much, to the point that it's just kind of overly messy. but I still feel that the comments are well done. The only thing I would add is a header comment telling what this file or what this code actually does. That is definitely something that needs to be in there that is currently missing. Variables are properly defined. For the most part, everything makes sense based on what it is doing, and it's pretty easy to understand where each variable is relating to based on its name. The only thing I would change regarding that, or I guess this isn't even regarding variables, this is going back to formatting. This is a bit messy here. There's a lot of definitions here, and this needs to be cleaned up to make it more readable and less of a big mess of text. When it comes to the arithmetic operations, they are done pretty well. Everything is done in these translation and rotation scales for actually drawing the objects, and the way these are done, nothing is being divided and nothing is being combined with larger enough. Everything is of an equal scale, and it all increments in nice manners. The floating point numbers are all being used properly, and because there's no division or really multiplication to this at all, they're all being incremented and rounded nicely, to say the least. When it comes to loops and branches, the majority of the loops and branches here also work well. For the face numbers, I guess I would say this is big O of n for the majority of these loops, as there's usually a different rotation number or a different face number, so it's big O of n on these. And due to the way this is built, I don't believe there's much of a good way to get that lower. So that'll probably have to stay the same currently. However, I do want to work on actually changing the efficiency, as there are some redundant calls related to this. But we'll get to that in just a second. We'll keep on this if-else statement. For all the if-else statements, the most common case is tested first. That way we do not have to go through the full if-else statement. And there's really not too many loops in this code other than the drawing itself and the render loop. So there's not too much to worry about there. So next we can get to all of the output variables, which all make sense, and everything being returned makes sense for what it is doing. Everything being placed on the screen is working properly, it's being assigned properly, and it is doing what it is supposed to. And memory allocation is definitely something that needs to be looked at with this code. Currently it is being handled well, as we don't want, because we have so many things we have to render, we don't want to mess something up when it comes to the texture or the wrong VAO, which is why every single time we bind a new texture or get a new VAO or a new VAO, as soon as we draw our object, we are always unbinding it. That way we are ready and allocated or deallocated for the next object we are planning on binding. The one other big problem that I want to reach out is just inefficiency on how many times these draw functions are called. There's a lot of information passed through each one, and that works for this rectangle function because each of the faces of the monitor require a different value, a different position and scale to work. However, the tarantula legs, that is not the same case. These are all the same. The only difference is their rotation and position. So this could be drastically reduced by just calling this once and having it draw all 10 at the same time. And that is actually one of my plans for enhancement, is I want to make this more efficient. I want to see these places where we don't need to call these draw functions as many times, and where I can really push down the amount of code on this file, because there is a lot of code on this file, and it can get a little overwhelming. So for my enhancement, I plan on taking this code and removing all of these except for one. That way, when this one draw cylinder sphere is called, the function is just going to take that for loop, it's going to draw the one leg, and then it is going to have a loop where it draws all 10 legs in succession while just slightly rotating each one to get the same effect as calling it 10 separate times. So that is the first enhancement that I would like to make for this, as my goal for this artifact is to really increase the complexity of the project, but I also want to increase the efficiency as well. And this enhancement that I just stated will be related to the efficiency. When it comes to the complexity, I want to allow the user a little more manipulation with the actual render, and to do that, I want them to be able to manipulate the light. So I plan on having a new keyboard input that allows the user to press a button, say F, and based on their current camera position, the light will be moved to that position. That way they can view the object. Or if the user doesn't want to manually move the light, they can press a button, say G, and the light is going to automatically rotate around the scene to light up the scene. And then the other way of increasing the complexity is to add animation, as I feel the animation is something I've never worked with, and it will be a very good learning experience to determine what I'm able to do with this project. So for the animation, I want to focus on the baseball and the tarantula. So for the baseball, I will have a function that's called each frame that's going to increase the scale of each one of these little sections so that the ball will get bigger, and increase the position of it so that the bottom always stays on this table. And then once it reaches a certain point, it's going to start decreasing the scale back down until it gets to this point. For the tarantula, I'm going to have a similar function called each frame, where these legs are going to have their rotation, I believe, on the y-axis. That may be wrong. Might be the z-axis, but basically these legs will be angled up slightly each frame until, and the body as well. The body's position will be positioned upwards a little more each frame until it looks like the tarantula is sort of standing. And then once it reaches a certain point again, it's going to revert until it reaches back to this point right here. So those are my enhancement plans to really bring this project to the next level and also fix a few of the problems that I've seen with this project. And overall, the outcomes that I'm expecting or hoping to reach with this enhancement is to design and evaluate the computing solutions using algorithmic principles and computer science practices. And due to how much mathematics is kind of used with this project, I really want to see or show that I'm able to use these principles and the computer science principles that I have learned to come up with new solutions and figure out what trade-offs are worth it in order to increase or make the project better and more efficient. And I also want to demonstrate my ability to use well-founded and innovative techniques, skills, and tools for the purpose of implementing computer solutions that deliver value and accomplish industry-specific goals. So I want to show that I can take these solutions and these techniques and skills I've learned to reach these goals that I've set out and that the industry has set out to make better programs, more efficient programs, and reach these higher goals that are needed. So that is everything for category 1 and artifact 1. So let's move on to artifact 2 and category 2 now. For artifact 2, algorithms and data structure, I have chosen my final project for IT312, which is software development with C++.NET. So this final project was creating a dice game, in my case the Farkle dice game, in C++ that would be able to be utilized on the console. So we can see here there's a few different classes we have. We have the actual Farkle game C++ file itself. We have the game CPP file, game header, player CPP and player header, and then player options. So real quick, we'll just head over to these. So the player options just is a list of what the player is able to do, where they're able to roll, keep, remove die, end their turn, see the rules, exit, or nothing. The player header file creates the player objects to basically keep data for each of the players. So we have our name, score, whether they've entered the game, if they have 6 point, or if they're winning, and the functions to set these variables and get these variables. And the player CPP file just contains the actual constructors and the and the functions to get and return these variables. The game file is where the game is actually played. So we have a lot of stuff in here for the game number, the current player, the player list, and then our 2 arrays for rollable and stored dice, and then all of our functions for the game. We have functions for input verification, the game setup, setting up the players, the game rules, turn options, the displaying the dice, displaying the winner, displaying Farkle when a player receives a Farkle, ending the game, and then actual gameplay functions for rolling the dice, checking point dice, checking a 3-point match, calculating a score, keeping dice, removing dice, and ending the turn. And then our 2 public functions for gameplay loop and get game over. And so starting out with the Farkle game, we first display our title screen, and then we get an input from a user for what they want to do, whether that's starting the game or exiting, and we verify that to make sure that it's 1, a number, and 2, matches one of these 2 inputs. If it doesn't, we throw an exception, but if it does, we will start the game and create a new game, and then we will continue and call our game CPP file. So in this file, we have quite a lot going on. We basically first are setting up our actual game. So we set up the game, we set up the players, we show the game rules, and then from here, we can actually start playing the game. And we do have quite a bit of error handling in here when it comes to player input. We have input verification for strings and for integers to make sure that whatever they're trying to do, it is first off the right data type and it matches any of the given inputs that we have with the game. And so with everything started in input, we then all have our functions to actually play the game, where we first display our turn options and the current dice values. We then have, for when the game is actually won, we have this which will display the winner, the second place and third place if player count's greater than 2. And then we have our display Farkle message, which if a player receives a Farkle, this will be displayed on the screen before moving to the next player's turn. On game end, this happens when the final round has been entered. We figure out the current player's size, if's winning, and then we will basically display who is currently winning, who's in second, and who is in third, and then we will display that. And then we have our functions that allow the player to roll the dice and set the rollable dice array to the random numbers. Check for point dice, which will check to see if point dice are in the rollable dice, which would be either 1 or 5, or a match of 3. And we have this function here, which checks to see if there's a match of 3 within the array. And then we have the function that allows users to keep dice in their storage or remove dice from their storage. And then we have the turn end, which will move to the player's current turn to the next player's turn. We have the calculate score function, which calculates the current score of the player in question. And then our actual gameplay loop, which sets up our game, gets the current player size, and then loops through each player's turn, allowing them to choose their options and play the game. That is essentially the functionality of this code. We can do a quick test real quick in the console. We can see we have this. We'll start our game. We have our rules, so we'll enter that, and then we say we have 2 players, Dylan and Josh. I would like to continue, and now we have this. So we can roll our dice, and I got a Farkle immediately. That is unlucky. But we can roll the dice, keep, say, dice 1, and dice 5 as well, because that's a point dice. And now I can go back, and my current score is 100, but I need 1,000 to enter the game. But I can say remove dice as well, come back, and keep rolling, or I can just exit the game. So when it comes to the functionality of this game, everything works as intended. It's correctly implemented. The Farkle game works according to the Farkle rules. The only difference is there are some additional scoring options in Farkle that are not implemented in this version. So I would like to implement those in my enhancement. But as for the original design, this does correctly implement that. And it also conforms fairly well to the actual coding standards of keeping good formatting between different functions. Everything is spaced well. Everything is named accurately so that it makes sense for what it is doing. All the if-else statements are properly indented based on what they need and how they are nested into the functions or into each other. And for the most part, all of this code is pretty pertinent to actually making this game run. So there's nothing really here that is unnecessary for the current state of how this code is actually put into place. When the enhancement comes, there are going to be some areas that aren't needed anymore. So I will get rid of those. But in the current state, everything makes sense. The comments for this code is very well commented. Sometimes maybe a little too much. There are some areas in here that I've noticed where I have comments that just really aren't needed. It's pretty self-explanatory what it's actually doing, and the comments just kind of a little more messy and not needed. But for the most part, everything is good. All the mathematical operations taking place are working well. There's no floating point numbers being checked. Everything is in integers. So rounding errors are not a problem, and everything is fairly well or fairly similar size-wise when it's being added to each other. For the loops and branches, there's quite a lot here, but everything is decently optimized for what it is doing. For instance, our input verification is checking the most common cases first for the input on what it is, what should be input, so that it's not going through the rest of the if-else statements every single time. And that's how it is for all of the if-else statements. There are a few such as with checking the point dice, that should be improved, and I will improve those, as they aren't necessarily checking the most efficient ones first or the most common ones first. So those will definitely need to be updated to make this work more efficiently. And then for the loops, the majority of the loops are necessary once again for the current state of this code. They need to loop through each of the arrays to determine the current stored values and the current rollable values. However, for my enhancement, I plan on swapping the data structure from this double array system I currently have to just a single array system that's an object of, or a dice array object array. And that will allow me to actually get rid of a lot of redundant loops with that new algorithm. Because, well, it won't necessarily change the time complexity of these algorithms, as they're always working with a constant number, because there's always 6 that needs to be looped through, because there's 6 dice you can use, so 6 will always need to be looped through no matter what. So with this double array versus that array of dice objects, it is always going to be big O of 1 for the time complexity. However, changing to this new algorithm structure is going to allow for the storage amount or the space amount that this takes up in the actual code to be vastly decreased, as well as the efficiency to be increased, as the majority of these functions, such as if I come over here to calculating the point dice, or these two functions actually, the majority of these functions are checking through 2 separate arrays each time, and every time we need to check for a point dice during a player's turn, which can happen multiple times, we always need to call this check point dice function and check 3-point match. So these functions are constantly being called, and the loop is constantly being run through multiple times for a player's turn. However, swapping to the new system will allow me to remove these, because these are redundant, and we will only need to check one time whether something's a point dice, in which we can mark that it is, and we'll need just a single loop with a single if-else statement saying if they are a point dice, instead of checking to all these different values. We don't have much going on relating to data or memory allocation with this. However, we do have a file that is being used for our rules, which I believe is somewhere over here. Yes. So for our rules of the game, we do have a file we're checking. So we do have errors catching for this file. We're basically trying to open it, checking to see if that works, and if it doesn't, we're throwing some exceptions for a problem, whether that was a problem reading the file or whether the file can't even be found. So there are definitely some things that can be improved with this code. There's quite a couple of errors with it, and I plan on just fixing a few of those before the enhancement. But for my actual enhancement, I plan on first restructuring this entire data algorithm to get rid of these 2 arrays and replace it with a new class. So it'll be one single array of a dice object class. And this dice object class will be able to hold values such as the dice value, what the current, if the current dice is a point dice, whether it's already been used or whether it's already been calculated, something along those lines. And this will allow the program to run more efficiently, as we're only looping through 1 array now instead of 2 arrays each time, and we won't need to constantly check each value of a dice against multiple different constraints to figure out whether it's a point dice. We only need to check it at the very start of the player's roll, where we can then just check to see, is this marked as a point dice? Yes, then we can do this. So that is my first plan. or my first section of the enhancement is just restructuring that. Once I have that restructured, I will then be able to kind of redo the scoring system, as this scoring system, or calculating the scoring system, is also pretty inefficient for how it's currently set up. If I can find this function real quick, because currently we have a lot of nested if-else statements and a nested for loop here as well, where we're essentially just checking a lot of stuff for whether some dice are stored, checking to see if they're a match, checking different matches, whether the stored dice is actually valid to get these different points. I plan on reworking this whole system to make it so we just have one loop that counts the numbers, because you can only have 1 through 6 in a dice roll. So I want to count how many dice are 1, how many are 2, how many are 3, and so on, where I can then take this whole setup and just change it to a simple if, else if, else if, else statement. So I will do the 1 for loop and then check to say if there is a 1, then we'll add 100. If there's a 2, if there's 3 2s, we'll add that point. If there's a 5, we'll add that point, and so on. And that'll make it much more efficient, as we just have that one loop checking through the one simple algorithm. And once again, time complexity will stay the same, big O of 1. However, the space complexity is going to be vastly shrunk, along with the actual efficiency of running this algorithm, as it's not going to have to go through so many loops and if-else statements. And that is my plan for enhancing this project to increase the overall optimization that this code has. And the course outcomes I plan on achieving with this project are to design and evaluate computing solutions that solve a given problem using algorithmic principles and computer science practices and standards, while maintaining the trade-offs involved in design choices. So obviously there will be a little bit of a trade-off changing to the object class system, as you'll have to create a whole nother class to store this data. But overall, I feel this project will be really good in showing that I am able to use these algorithmic principles and practices I have learned to create better solutions for a project. I also plan on using the design, develop, and deliver professional quality oral, written, and visual communications. As well, this isn't a very professional project. It shows how I'm able to communicate and give visual feedback or representation to less professional clients, and this would relate to even professional, as since this is less professional, as you're going to just have some casual people wanting to play a game, I can show how I can clearly communicate what they're playing, the different options they have in a very short and specific manner so that they know exactly which each option is. And lastly, I'll demonstrate the ability to use well-founded and innovative techniques and skills and tools to implement computer solutions that deliver value and accomplish industry-specific goals. And this project shows that really well, as I'll be able to show how I come up with solutions and I can provide value and increase the optimization of a project with my new ideas. So that is Artifact 2 for Category 2. So now let us move on to Category 3 and Artifact 3. Alright, for Artifact 3, this is for the databases category. I have chosen my project from CS250, which is the Software Development and Lifecycle class. So this project basically creates a simple slideshow of 5 different travel destinations with a picture, an image, and a button that allows a user to move between them. So starting off with the functionality of this code, it's very simple, very short code. But basically, we are declaring our variables up top. We're creating the actual application and initializing the contents of this application. And then we set up our frame, we set up the layout, and then we have this for loop, which adds each of the slides and text by getting the different images and descriptions. And then we set up our buttons for our previous button and our next button, quickly set up their functionality. And then these are our two methods that actually get the images and the description for each of the 5 tabs. And then we launch the application. So we can do this pretty straightforward. And this is going to throw this up on the screen, and we can hit next or previous to go between all 5 of the locations. So when it comes to the analysis of this code, once again, this does correctly implement the original design that was output for this code. The variables, or I guess the actual coding standards, make sense. Everything's well spaced and properly placed. The only thing I would say is maybe formatting wise could be a little better, like throwing these down, just making it a little nicer. But once again, it's nothing too crazy going on with this code. The only, or one of the main complaints I'd say is commenting on this code is pretty minimal. Once again, it's minimal code, but I feel that the comments could definitely be a little better in stating what is exactly going on in this code. And there's no header comment stating what this code's meant to do, who created this code, or anything similar. So adding that would definitely be a benefit. Everything in this code is necessary for this to run. There's nothing unusable or nothing being left behind here. And once again, there's no storage happening as we have everything hard-coded in, which is definitely something I want to remove when it comes to my enhancement. Variables all make sense here. Everything is pretty much short and also tells exactly what it is so that you don't get confused. We don't have any operations mathematically. We only have one loop, which is necessary to set up the actual cards. And then we have a few if-else statements relating to getting the different images and strings. And once again, we don't really have anything relating to storage with this code, or files for that matter. So when it comes to my enhancement, I plan on completely redoing some of this to add a database first, and that database is going to be able to securely store both the images themselves as well as the text description. That way we don't need any of this hard-coded in. Everything's in the database so that we can manipulate the database to either add more or remove certain resources instead of having to go into the code itself to perform that. Once this database is created, I want to swap this to, instead of displaying on its own window, I will create an HTML interface that will create a small front-end website that displays these as cards on the screen. And on that interface, a normal user will be able to just search through and look at the cards and the descriptions. However, I will create a login system where an admin can create their login, which once again, the logins will be stored within the database. They'll be able to use a login, and using that login, they will be brought to a different screen that's very similar. It will still have the same card setup. However, there the admin will be able to either add or remove records from the database. to add new travel destinations or remove these travel destinations. That is my main enhancement plan for this project. There's a lot to do with this one, and I don't have much experience when it comes to front end, so this is going to be definitely a huge step and a lot of work, but I think it will provide to be very useful to me in my growth. And the outcome that I'm hoping to achieve with this, the main one is to employ strategies for building a collaborative environment that enable diverse audience to support organizational decision making in the field of computer science. I feel that this will be really well, as it brings multiple softwares together, as well as bringing the client and the company together to build this sort of collaborative environment where everyone can state their opinions or state whether they like something or not, and basically work together to build this program. And then I also will achieve the develop a security mindset that anticipates adversarial exploits in software architecture and designs to expose potential vulnerabilities, mitigate design flaws, and ensure privacy and enhance security of data and resources. And I plan on doing that via the use of the database, creating a secure database that only authorized users are able to access, so that the front-end site is able to securely display all this information without giving any personal info away or allowing any unauthorized users to manipulate this data. So this was Artifact 2, or sorry, Artifact 3, my bad. This was Artifact 3 for Category 3, and that is the end of my code review. So thank you, and have a good day.